Hi, so let's try to bring things together a little bit now and load an object file and then ray trace that. I'll just head over to the project here. Now, I've set this up in a sort of step-by-step fashion. So if we go over to the scene, we can see that we're now importing this object mesh. But then if we go down, we've got this make scene function, and here we have a bunch of these to-dos that we need to do. So first of all, I'll just follow through the process of how this will work. Oh, I just realized we should probably get rid of this line because we want to build the bounding volume hierarchy after we've loaded everything in. Okay, so where was I? So what we'll do is we'll set a few things up, then we'll have this make scene function which will finalize the setup. And what that will do is it will load from this object model into this statue and parse that data, read the file, construct a bunch of triangles, and then what we want to do is get the bunch of triangles from the model which were created, put them into our triangle list, so we're capturing all the triangles which were loaded in the file, and then we can go through the normal process of building the bounding volume hierarchy. Now, if we go onto the, where are we? The object mesh. For the most part, this is the exact same object mesh file that I had in the object file video, but we do need to adjust it. So things like buffer, we don't need that. Instead, this is just going to consume a file and store its data in a set of triangles. So where was I? So we'll go through, we'll have this list of triangles, and there are a few steps here, but basically what we'll do is we'll take color as an argument. So we'll say, hey, load this model and I want the thing to be green, load this model and I want the thing to be white or red or something. So we'll just store that in a variable, and then we'll jump into reading the file and we'll take it from there. Now, on the triangle side, originally I just had this build from center and offsets, which is fine. It's a pretty good way to make triangles if you want to randomize a whole bunch of triangles. However, let's set this up now so that we have a constructor which zeroes out a few things and some function to build the centroid of the triangle. So that was the high level overview. The rest of this should, fingers crossed, be working okay. But I've just noticed something. If we go to the scene, see that this make scene is an asynchronous function. And as a matter of fact, in the renderer, of course, the initialize function is asynchronous. However, if we go to the main function, these are not being used asynchronously. So what we should do is await them. And as a matter of fact, that was the first item I wanted to do here. So we can cross that off. That is done. We are now awaiting those functions. But as you can see, we're getting some errors. So let's hover over here. It says top level await, whoops, are only allowed when the module option is set to ES 2020 or so on and so on. So we need to set, I'm going to set the module option to ES 2022 and the target option to ES 2017. Why not? Now that is in this, I think it's the TS config. Yeah, okay. So see here we have target. I'm going to change that to ES 2017. Okay. And module down below was ES6. I'm going to change that to ES 2022. Okay. Just save that. And then if we go back to the main function, those errors are gone. Fingers crossed it should now be working properly. Okay. So now I'll go to, let's go to the scene. So in the scene, let me look here. This is all looking fine. Yeah, I'm happy with that. I'm actually going to get rid of this line here. Yeah, I'll initialize that in the make scene function. Okay, so what was I to do? The object mesh doesn't need to make buffers or anything like that, which means we don't need to pass in a device. If we hover over here, we can see the first argument is a GPU device. We're not going to do that. Instead, what I'll do is I'll set the first argument to a color. By the way, feel free to pause the video at any point if you see a to-do item and you want to work on it. Let's make this a little bit bigger. Okay, now get the triangle data from the loaded model and put it into the triangle list. Well, the first thing I'll do is I'll just initialize to an empty list. And then, okay. So let's go get the statues. It's probably better if I build it from the top up, actually. Change my mind. Let's go, yeah, let's go triangle. We'll go from there. Okay. So we have corners, color, and centroid. Just initialize this to a blank list. And then I'll make the make centroid function. So the make centroid function is assuming that corners now has been populated and is a list of 3 vertices. So we'll say so using data which is already set in here, we'll set the centroid. Okay, so this is going through the 3 corners and getting the x coordinate of each and just taking the average of those 3 x coordinates. Nice and straightforward. And you're probably yelling at me right now, can we use loops? Yeah, absolutely. Absolutely we can use loops for this. I just wanted to do it this way, why not? So this point represents the average of all the x, y, and z coordinates. I'll use that later on when I'm building the bounding volume hierarchy as an idea of where each triangle is situated. It's the midpoint. So we can close that down and then go to the object mesh. Okay, so to do, remove the buffer stuff. Okay, we don't need this stuff. That's gone. Okay, make an array of triangles to store and add a variable to track the color of the model. Okay, no worries. So I'll make this variable, I'll call it triangles, and it will be an array, but of course I will need to import that triangle class. Okay, excellent. And then I'll track a color. So right now I'll just have a constant color for the whole model. Later on I'll do textures, but this is fine. That'd be a vec3. Okay. Okay, to do, initialize the triangle list. No worries. So when we make a list, we always need to initialize it, and that can just be as simple as declaring a blank array. Okay, now down here, take a color instead of a device. No worries, because we're not building a buffer here. we're just basically reading a data into memory, reading a file into memory. Okay, store the color and load the file. Well, we're loading the file down here, so we'll just say store the color. Okay, now all of this stuff has to do really with constructing the buffer, but we're not using one of those, so we can just get rid of all these lines. And we probably could have just taken the contents of that read file function and put it in here, but also we don't have to. Okay, excellent. So that is fine. That's fine as well. Yep, this bit is fine, except down here where we convert the result into a float 32 array. We don't need that. Okay, read vertex data. Yep, no worries. Text coordinate, normal, no worries at all. Okay, now, what are we doing here? Okay, so reading face data. But first of all, I just want to go to read corner. By the way, this video will make a lot of sense if you've looked at my previous video on loading object models. But okay, so what I want to do now is set this read corner so that it reads the line that it needs to read and then returns the data that is relevant. So what I'll do is I just want to return the position down here and say return the position, which is V. And while I'm at it, I'll also read in the normal of the vertex so that at least later on I'll have a complete implementation, even if I'm not using it yet. Okay, so as you can see, this takes a line which is in the form v/vt/vn, and it accesses the data which has been loaded in the previous functions, indexes into the correct variable vector, and we get all of these. We have access to all the position, texture, and normal. Right now I'm just using the position. Okay, so then the question is, we've got this function which is returning the position. How do we use this to build a triangle? So what I'll do is we'll go make a triangle. So that will set all of the corners to a blank list. So we can say, okay, triangles corners, push on these corners one at a time. Okay, while we're at it, let's say the triangle's color. We'll set that to the color which we have stored in memory, and then we'll also tell that triangle to make it centroid, and then we'll push that onto our set of triangles. Good, good, good. All right, so this to do is to done. And fingers crossed, there might be more to it, but I think that is everything I needed to do to implement the object mesh. Okay, so back to the scene. So where was I? What I want to do is go through each triangle in the scene and put it onto our set of triangles. So I'll say the temporary variable will be called triangle. What we'll do with that is, now I did have this variable up above, triangle count. I will initialize it just in case to cover myself. I should, yeah, this is a whole thing, but let's go. Right, so fingers crossed this should be working. So I'll just go new terminal and then npm start. Oh no. Okay, so if we go right up the top, it says top level await experiment is not enabled. So we need to set experiments top level true to enable it. So what this is saying is in the main, I set some flags to say, hey, I want to be able to await an asynchronous function from a top level script. And this is saying, oh, well, hey, hold on there. Even though there was no obvious error at compile time, or not compile time, but you know what I mean. Even though there was no obvious error in VS Code, it turns out you do need to set this option. So I looked around and it turns out this is set in the TypeScript config. Oh, no. In the Webpack config, I mean. And it's just as simple as setting this. Okay, so it's experiments. So this is an experimental feature, and the one we're after is top level await, and I'll set that to true. Okay, so now let's try this again. So we'll just go load that up. Okay, that's working. Just get that. Open it in Chrome Canary. Yeah, so it is displaying something. And if we inspect the page, there are no errors. So I'm happy with that. It's a little dodgy that our object count is not being set correctly, but that's actually easy enough to fix. We can just go back to the main. And the issue is that I'm setting this, and then you can see what I'm doing here. I'm setting this and reading it. I'm not actually looking at what the scene says. So just go down below. After we make the scene, then we can go take the scene's triangle count. Okay, so now we can see that we are loading in 2 triangles. It's just not visible. And that's okay, because the little test model that I've got here is a flat plane, is a piece of ground. It could just potentially be at our eye level or something. Actually, we can, what am I thinking? We can test that. Let me quickly see if this works. It might not. I do suspect that this camera code is a little dodgy, but if we move the camera up or down, then maybe it won't be directly at our eye level anymore. Let's just leave that. Okay, so let's pretend that that's working. I think I do need to troubleshoot that triangle code a little bit more, but I mean, let's pretend that that's working and load the statue model from the server. So this is in the dist folder in the repo. And now you can see that the model is loading, more or less. We have about 31,000 triangles. We're loading it pretty quickly. Now, this is another reason I say this is slightly dodgy, because you can see that it's all black, even though I initialized it with a white color. So first up, let's bring the camera a little bit closer. Okay. And a model will only be black if a ray keeps bouncing around and keeps repeatedly hitting things. So I guess, for instance, these rays must be bouncing around and continually hitting their own geometry or something. So what I'll do is I'll just go to the Raytracer kernel, and right down here in ray color, this is the line. So if we go through the whole loop and we keep hitting things, even at the end, let's just do nothing. Okay, it's white. So what we probably would want to do is incorporate a transform matrix, either to just pre-transform all the data upon load, or to be able to change things on the fly. But yeah, I'm going to leave this for now. We can see that it is more or less. Hello, hi, this is Robot Andrew from the future. I fixed the problem. Looks very nice. Looks pretty cool. Can you guess what the issue was? It was in the triangle code. So what I've done is I put that back in. So if the ray keeps bouncing indefinitely, it should terminate to black. I just had that as a temporary. But in the hit triangle code, when I found the normal, I did it by taking the cross product. I should have normalized the result. I guess what was happening is the normal was too large or something weird. I'll just say that. Yeah, so the normal was too large, so when the input vector reflected around that, it was shooting backwards or something. Something weird. But now, as far as I can see, it looks to be working pretty well. Looks very cool. Very cool. And performance is going well as well. So anyway, I'm thankful that I found that. It was pretty easy. And yeah, I will see you again in the next one. We got a whole bunch of these working together. All right. Thanks. Bye.